Welcome back to Section 5 of Chapter 5. This section will actually be a lot like Section 4, even though it doesn't say anything about completing the squares. We're going to be looking at complex numbers and roots, but we get there by completing the square a lot of times. And what happens, in a nutshell, is we get x squared equals a negative number, and we have to figure out how to deal with that. So it's like a little twist in the last step of solving the problems that we've been trying to solve. So let's take a look at our learning targets. I can define and use imaginary and complex numbers. Yes, we have to use our imagination. And I can solve quadratic equations with complex roots. And so the first question is complex number. What is a complex number? It sounds kind of hard because complex has a couple different definitions, one of which is hard. But that's not the definition we're using now. The definition we're using is it has multiple parts, like a housing complex has multiple houses, an apartment complex, a sports complex, that all has multiple parts to it. Well, what are the multiple parts of a complex number? An example of a complex number is something like this, 12 minus 3i. The two parts are this part, the 12, that's the real part, and the 3i, negative 3i, which is the imaginary part would be negative 3. And so it has two parts to it. And so what is I? I is called the imaginary unit. And if we have something like the square root of negative 9, we get, well, we can't take the square root of negative 9, right? You've been told that for years. You can't take the square root of a negative number. Well, that's not entirely true. You can't take the square root of a negative number and get a real number. However, the square root of negative 9 is an imaginary number, and that's where the I comes in. It stands for the imaginary unit. It's an imaginary number. So what exactly is I? I is defined to be the square root of negative 1. That just equals I. And so how does it work in simplifying? If we have the square root of, say, negative 9, like we're looking at up here, remember that we can split this up using multiplication. This could be the square root of 9 times the square root of negative 1. The square root of 9 is 3. The square root of negative 1 is I. So this is just going to be 3i. Basically, we simplify exactly the same as we would if it was positive. We just have an I in there as well. Say the square root of negative 50. We're going to have an I, but what is the square root of 50 going to look like? Well, we can factor it. It's going to be 5 times 10. 10 is 2 times 5. So, hey, we have a pair of 5s. They can make a break for it, make it to the outside. We still have that 2 on the inside. So we have 5 root 2, but then we get an I. Or 5i root 2, because a lot of times we like having the root at the end, so you don't have to think, well, is this I inside the square root or not inside the square root? An I inside of a square root is a whole nother headache that we don't need to deal with. So putting it outside is perfectly fine as well. And what about the plus or minus? All of last section, it was always plus or minus, plus or minus, plus or minus. Well, remember that when we're simplifying, we just get 3i. The square root of 9 is 3. It is not plus or minus 3. The square root of 9 is 3. The plus or minus comes from when we're solving. If we have something squared equals a number and we square root both sides, that's where we get the plus or minus. And so this is the difference in this topic. Now, fun fact about imaginary numbers. I love imaginary numbers because most of math was created because there was a need for it. Someone was trying to solve a problem, and it couldn't be done with the math that they had. So they developed more parts of math. The whole complex numbers and imaginary numbers thing came about when someone said, oh, what if you can take the square root of a negative number? What then? And so then they developed this system which works. And it wasn't for quite a while after that until they actually found applications and uses for it. But there are applications. Electrical engineering is one of them. They use imaginary numbers all the time. And it's just fantastic. Like, it's math that someone just thought, hey, why not? Let's try it and see what happens. And then later on, they found a use for it. I mean, it's fascinating. You don't sound as thrilled as I am. You should be. This is good stuff. So, how are we going to use this with solving equations and finding roots? Well, if we have questions just like last time, we have 5 times something squared equals negative 80. First step, divide by 5. X squared equals negative 16. And then square root both sides. We're solving by square rooting. So square root, we get x equals plus or minus the square root of negative 16. The square root of 16 is 4. That negative will just add an I to it. So you get x equals plus or minus 4i. That's the difference. Was that really any different than just having 5x squared equals 80? Not particularly. So this topic, if you get the last topic, completing the square, this is going to be easy. Speaking of completing the square, let's take a look at completing the square. So we're going to solve this function by completing the square. And so we first need to make g of x equals 0. Then we need to subtract the 34 over because we want the x's on one side and the constants on the other. Notice I left space because we're going to have to do some adding. Get our next step. We'll have x plus or minus something squared. And so to get there, remember, we're going to take this number, divide by 2 to get plus 3, and then square it to add it here. But if we add it here, we have to add it over here. And so this x squared plus 6x plus 9 factors into x plus 3 squared. I know people ask, well, where does this extra plus 9 go? We put that here so that this would equal this last step. And then this plus 9 has to add to this negative 34 to make negative 25. Now we can square root both sides. So we get plus or minus the square root of negative 25 equals x plus 3. Let's see, the square root of 25 is just 5. The negative will put an I on it, so we get plus or minus 5i. And then we just need to subtract the 3. So negative 3 plus or minus 5i equals x. Can't combine these. It's just like if we had a square root there. This is just negative 3 plus or minus 5i. And so that is the difference with completing the square. Notice it's the same, only we had this negative. And you might be thinking, wow, it's got to get a lot harder. Like, we're going to probably have to add the i's, multiply the i's, and do weird stuff with that. And yes, you are right, but that is not today. That'll be the very last section of the chapter. We'll come back and look at how we work with the imaginary numbers and complex numbers. Right now, it just shows up in your answer. So try one. Well, actually, you're going to try two, but first try one. X squared plus 49 equals 0. It's going to be a lot like this one. So go ahead and pause this. Do it. It should only really take a few seconds, and then go ahead and push play when you're ready. Was that easy? How'd you do? Did you first start by subtracting 49 and then square rooting both sides? Let's see, square root of 49 is 7. There's a negative, so that'll make it x equals plus or minus 7i. Did that one go well? I hope so. If not, did you see what happened there? All right, try another one. And this one's going to be a lot more like this, where you have to complete the square. F of x equals x squared plus 2x plus 3. Go ahead and pause this, complete the square, get your answer, and then come back when you're done. All right, so how'd you do this time? That one was a little bit harder. Well, let's see. First, we need to make the f of x equals 0, and we can subtract the 3 over. So we get negative 3, leave a space, equals x squared plus 2x. We'll need the next line, x plus something squared. Well, divide by 2, so that'll be x plus 1. When we square 1, we get 1, so plus 1 plus 1. Negative 3 plus 1 is negative 2. Square root both sides. So we get plus or minus the square root of negative 2 equals x plus 1. So the negative will make an I, and what's the square root of 2? It's just the square root of 2. So it'll be plus or minus I root 2. Subtract the 1, negative 1 plus or minus I root 2 equals x. Remember, just like with the ones from the other completing the square, sometimes the roots don't simplify. You can leave the root in the answer. Same thing if there's an I with it. Negative 1 plus or minus I root 2 equals x. How'd that one go? So if you can complete the square, it's pretty easy. If you're struggling with completing the square, are you following the steps here? All right, how about some other types of problems that we might see today? One type, and this type looks way harder than it actually is. So it'll say find x and y if, and then it'll give you a big equation. A complex number equals another complex number. And you might remember chapter 3, like we have two variables, we need two equations. Yeah, and kind of no. In these cases, we can look, if we have a complex number equals a complex number, the real parts have to be equal, and the imaginary parts have to be equal. Y isn't going to equal something that's going to get it away from this I. And so the real parts, which would be this 5x plus 1 and the negative 20, have to equal each other. 5 times x plus 1 equals negative 20. And the imaginary parts, 3y, has to equal negative 15. Now, technically, the I is not part of the imaginary part. It tells you which part is the imaginary part, but it is not actually part of it. If you happen to forget that in this step, you get 3yi equals negative 15i. The i's just divide off, and you're left with 3y equals negative 15. It should work out okay. All right, so over here to the real part, the red part. We can divide by 5. X plus 1 equals negative 4. Subtract 1. X equals negative 5. And then the imaginary part, 3y equals negative 15. So y also happens to equal negative 5, which is coincidental that they both equal the same thing. But notice how the problem looks pretty hard in the beginning, but just take the real parts together, the imaginary parts together, and these problems are super easy. The other type of problem you might see would be identify the complex conjugate. So if you remember back when we were dealing with square roots, the conjugate, we just changed the sign. Same thing with the complex conjugate. It's just the other root. So you're going to have something plus an I, and then something minus the I. It's the plus or minus gives you the conjugates. So if we have 3 plus 2i, the complex conjugate is 3 minus 2i. Notice this would go to 3 plus or minus 2i. That's what one of our answers would look like. If we have 7 minus I root 5, the complex conjugate, just change the sign of the imaginary part, 7 plus I root 5. Now this one's a little bit tricky. I plus 6, we have to change the part on the imaginary part, change the sign of the imaginary part. And so I plus 6 is not I minus 6, it's negative I plus 6. Because think about it, this one could be written as 6 plus I, then it would be 6 minus I. That's this one. And how about if we just have 4i? The other root to 4i is just negative 4i. This would be 0 plus 4i, 0 minus 4i. And that's it. So those are the other types of problems. So we're going to be solving using square roots and completing the square. Only we're going to have something squared equals a negative number. We're going to have an I in the answer. And then some problems like this, and some complex conjugate ones, which require absolutely zero work. You just write down the answer. And so that's what we'll be working on this time. So I will see you later. Until then, happy mathing.